Hello! Today we're going to explore the string, the most basic and common Redis data type. We'll see just how powerful this little guy can be. Redis strings are binary safe sequences of bytes, and they're a lot like the strings you use in your favorite programming language. You can store almost anything you can imagine in a Redis string. Integers, binary values, comma-separated values, serialized JSON. And since they're binary safe, you can even store larger objects such as images, videos, documents, and sound. So what are some practical uses for Redis strings? The most common use is for caching. API responses, session storage, HTML pages, the opportunities are vast. Redis strings are also great for implementing counters, as there is built-in support for incrementing and decrementing integer and floating point values. Today we're going to go over a couple examples using the Redis string. First, we'll cover how to store and retrieve a string. Second, we'll examine a use case of storing a JSON object as a string and how to set an expiration time until its deletion. We'll also discuss the implications of storing JSON as a string and a couple of alternatives within Redis. Lastly, we'll learn how to increment and decrement an integer value within a Redis string. To create a string in Redis, you'll use the set command. After the set keyword, you specify the key followed by the value you want to associate with it. For example, let's create a time zone entry for a user of an application that we're building. I'll use user:101:timezone as the key and UTC-8 as the value. Redis returns OK, which means that the time zone string was successfully stored at key user:101:timezone. To retrieve a Redis string, you use the get command followed by the key you want to retrieve. Let's now get the user's time zone. Redis returns the value of the key as a string. Let's consider an example use of strings. Imagine you want to provide your user with site usage data. Normally, you'd send the request to a data warehouse, which might take several seconds to complete. But by using a string, you can cache this JSON response after initially fetching it, as these responses don't change often. Here we have a sample JSON response containing a user's recent site usage request. Instead of accessing our data warehouse for this information on subsequent requests, we can cache this response as a string within Redis. Let's assign this information to the key usage:63. When caching data, it's common to set an expiry time. Here we'll do that by adding the EX option to our set command, followed by a number of seconds. EX specifies a time in seconds after which Redis will expire and delete the key and its associated string value. So, this Redis string will now expire in 7,200 seconds or 2 hours. By using Redis as a cache, subsequent responses that might have taken several seconds to fetch from the data warehouse will instead be served instantly. We can check on the remaining time to live for a key by using the TTL command. TTL returns the number of seconds remaining before the key expires. Now, expiry is a complex enough topic to warrant its own video segment, so check back soon for a dedicated video. Lastly, let's check out the abilities of the Redis string in regards to integer manipulation. With the incr and incrby commands, you can increment a key's value by 1 or by a specified number. You can also use a negative number, which will decrement the value. If there is no key already present, the incr and incrby commands will create a new string and increment its value appropriately. To see how that works, let's run the incr command with a key that doesn't exist yet. Since the key user:23:visitCount doesn't exist yet, the incr command simply creates a new key and string with a value of 1. This is the Redis way. If a data structure doesn't exist, then it will be created the moment you write to it. Now let's take a quick look at the incrby command. Incrby increments the value of a given key by a specified number we provide in the command line. Let's say we have a key user:23:credit balance with the value 40. Let's increase the value to 70 with the command incrby user:23:credit balance 30. Finally, let's reflect the usage of the available credits for this user by running incrby with a negative number. Let's say our user consumes 50 credits. The command would be incrby user:23:credit balance -50. Now the user has 20 credits left. Okay, so let's do a quick review of what we just covered for Redis strings. Strings are the fundamental Redis data type, and you can use them to store plain old strings, numerical values, serialized JSON, and anything that can be represented in binary. Strings, combined with key expiry, are your first go-to data structure for caching. Finally, you can also use Redis strings to store and manipulate numerical values. To learn more about Redis strings, check our free online course, Introduction to Redis Data Structures. It's part of Redis University, our free online learning platform for all things Redis. Thanks for joining me in this quick dive into Redis strings. Hope to see you again, and happy learning.